Hello, everyone. We're happy to have Mateus here with us today, and we're going to talk about blockchain technology in detail. Mateus, thank you so much for joining us. How are you today?
Doing great. Thanks for asking. Thanks for the opportunity.
Yes, sure. And my first question is imagine you're explaining blockchain technology to someone completely new to the concept. How would you describe it using everyday examples or analogies?
Thanks for the question. My best analogy it's that saying that a blockchain is a market for computation. Why is that? A lot of people think on it as a way of payment or a way to process transactions, but in the baseline, it's just a market for computation. Is people willing to have information included in that network using some cryptographic proof or some form of proof? And in the other side, you have people able to do this computation. And those people are not a centralized organization. They are not just a company or an institution. It's actually a network that connects those people. So it's just a market of supply and demand through a protocol called blockchain that unites people willing to have information included in that network with people that are available to do this computation, available to store this data and process the cryptographic proofs on that. So the idea of this network is, instead of having one central party doing this computation, you have a network to remove those middlemen, to remove the centralized players, and to check the players are behaving as they should, using that protocol to check that, instead of having one company, one single software, one single system, one single cluster to process it all.
Okay, so my next question is we often hear about blockchain's potential to revolutionize industries. Can you share a real world scenario where blockchain could bring significant positive change and explain how it would impact people's life?
Great question. Well, we can already see this happening in volume with the cross-chain, cross-border payments and the peer-to-peer payments that blockchains are being used to for years already. A lot of users already adopting this, a lot of volume being transacted in this use case. But cross-border payments or peer-to-peer transactions are just one iteration of data ownership. The same way that you can prove that you are on this asset that you're transacting, you can prove all the kind of data, all the kind of, for example, identity wallets, that you can prove your medical records, your financial data for credit score, your tastes for music, and this kind of data that belongs to you can be proven using blockchain network as well. A great implication of that usability could be for social networks. The same way that we can control our accounts nowadays into those centralized social networks using our email, phone, and passwords, we could see the same effect happening in decentralized social networks, where I have my followers, I have my likes, I have my content, and I can bring this with me for every network that I join. There are some great iterations of that happening already, and this could be a big potential for the blockchain technology out of the payments industry, for example.
And that is great answer. And my next question, blockchain networks are often associated with cryptocurrencies, but their applications extend beyond that. Can you give me an example of a non-financial use case where blockchain could provide unique benefits?
Well, that is a great follow-up question, because for those data ownership situations, for example, social networks and all of that, you have a perfect, not perfect, but a very apex solution of cryptographic proofs of shared data between the nodes in the network for anything that you want to do with this data. For example, DAOs. If you have governance power, if you have governance voice, if you have governance influence over things that you have in the world, the current Web2 world, and the current things we do nowadays in the internet, if you have that translated for your decentralized identity, your wallet, your signature, your tokens, if you want, this could be already a great improvement. You can use this network to account for everything that is flawed in current models of governance by removing those middlemen, sorting out the incentives, incentives for a good voting, incentives for a good delegation, incentives for a good compliance of the rules. This is just one of the many iterations that could happen by applying the same data ownership structure that we use for crypto payments in other areas or other applications that we use and we develop for the Web3 world.
And it is often said that blockchain has been described as a distributed ledger. Could you explain what a ledger is and why the distributed natural blockchain makes it valuable?
Perfect. Because the idea of a ledger is not so aliens for us. Even people that don't know the idea of a database, whatever, you can record things in a ledger not to forget again. So basically, if you want to understand it that way, it's easier for you. You can imagine a ledger as a place where you record information. The thing is, when you have a centralized ledger, you write it off in a place, you could forget it, or that place could be destroyed, or could be altered. Someone could commit a fraud there. So there are several problems that happens when you have centralized data storage, when you have centralized structure for controlling those information, when you have centralized ledgers. When you have this decentralized, when you give a little of data availability away by decentralizing this data, and now it's not just in one place. Now it is distributed through a lot of different nodes. When it's distributed in a lot of different participants, a lot of different nodes, now you don't have a single point of failure anymore. This brings lots of values because now you cannot be censored. No one can stop you from getting that information. It is now fault tolerant. You can have things going offline. You can have people even committing frauds. So long you have the majority of the network agreeing in that information, agreeing in that state shared between the nodes, you are safe to go. Thus, you gain something that we call Byzantine fault tolerant. You now have a BFT compliant solution by using this decentralized ledger.
Okay, and what are the key differences between permissioned and permissionless blockchains, and how do they affect the potential use cases?
Yeah, great question. Because even if those records, this ledger is decentralized, you still could apply an access control layer, that is something that checks who you are, checks your identity, checks if you have authentication for that identity, and checks if you have authorization. So a public blockchain, you don't check anything. Anyone can connect and draw information from it at any time. Thus the name public. If you implement any kind of access control layer beyond having internet, for example, for checking the information on blockchain, you still need to have internet. Okay, that doesn't count. Anything beyond that, if you need the user to identify, if you record the IP location, if you record the number of requests that the person is doing to that network, all of that, then you start implementing access layers. If you can block someone based in these access layers, it means giving authorization or not. If you have any kind of algorithm like this, based on who you are, I will give you authorization or not for reading this data, then it becomes a permissioned blockchain, a blockchain that, depending on some situations, I could be denied of access to it. There are some blockchains that need this kind of design, this kind of architecture, and there are some other blockchains that are against this kind of architecture that should not use access control because of what they intend to do.
All right, that's interesting. And can you discuss the potential impact of blockchain on financial inclusion, especially in regions with limited access to traditional banking services?
Well, that's nice because this goes back from one of the questions we had before. The things that blockchains enable as utilities are features. They are enabled by a network, not by an institution. So anyone that connects to that network can instantly get access to those features. So for example, you don't need to do paperwork. You don't need to show documents. You don't need to show identification. You can onboard to that network just by participating, just by plugging your computer. Like when you open a website, a social network, or entertainment platform, and then you subscribe for free, and then you can consume information. Blockchains like that. But in public blockchains, like not permissioned, in public blockchains, you can do it for free, even without identify yourself. So when you onboard, you have a sovereign ownership of that functionality of the things that you own there, of the assets that you can claim that are yours. And then for money, for information, and for lots of things that happen in those less represented places in the world, not speaking specifically about Brazil, but there are many countries where you have problems of supply in the currency, inflation, risks of assets being frozen, of assets being confiscated. All of this, just by connecting to that network, you are instantly protected for all of those things that are not compatible with most of the public blockchains that are out there. Just because of the design of the network, it can instantly resolve these kind of problems for whomever that is connected to it.
And blockchain networks often rely on cryptographic techniques. Can you explain in layperson's terms how cryptography contributes to the security and integrity of blockchain transactions?
Great follow-up question, because it just said that someone can connect to that network without doing paperwork and blah, 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 right? So how the network knows that the person is that person indeed? It is because of the cryptographic proofs. So you don't need to know into the detail that. You just know that you can prove that you are yourself without revealing your identity. How is that? Through a clever mechanism of public and private keys, where you don't need to create accounts. When you log into any service, a social network, you need to create an account first to register that account into the database, and then you can claim everything as yours, your profile picture and blah, blah, blah. In a blockchain, no, all the accounts are already created. Imagine like this, you have billions, much more than billions. You have more accounts in a blockchain than you have grains of sand into the earth. So you have an astronomical big amount, a huge amount of accounts there. To claim an account, the only thing you need to do is having a private key. And the probability of you discovering the private key of someone else like this is almost zero. It's practically zero. Statistically zero. So you don't need to check if there is someone using that account before or not. You just pick a pair of public and private keys. Don't pick an obvious private key like 00000, because the probability of someone already using that is big. So you should come up with a random private key. Once you come up with a random private key, you are good. These cryptographic systems allows you to interact with that account, saying that you are yourself. You can receive money to that account and sign transactions on behalf of that account without pre-registering, because you randomly picked an account that was available in that network for being used by choosing a cryptographic key pair of private key and public key.
Okay, Mateus, I have some unpleasant questions for you. What are some common misconceptions or misunderstandings about blockchain technology that you frequently encounter, and how do you address them?
The best one is like blockchain is just crypto. I know a lot of projects use tokens to a lot of things, for governance, for raising money, for giving utilities, yes, but blockchain is way beyond of crypto. I know there are blockchains focused in crypto, just the native token being transacted. This is great, okay, but you can do much more with it as well in other ecosystems, in other designs, in other architectures. So the topmost would be like this: blockchain is just crypto, and a lot of trainings, a lot of education, a lot of regulation in that industry. When you speak to blockchain, automatically speaks to crypto like they were the same thing. This is a big misconception that as soon needs to be changed. The sooner the better. We can also see situations of weird token economics out there, broken expectations of investment, of utilities in projects. This is something that creates a lot of noise into the ecosystem as well. It's difficult to measure hype of projects and food of news depending of the noise that you have. And for a newcomer to that environment, this is something specific to blockchain that I don't see in other industries. This happens in a lot of the industries, but not in the same level. The amount of noise, the amount of things to confuse people is huge because of those misconceptions that happen in blockchain.
And what are some potential solutions or strategies for achieving scalability in blockchain networks, allowing them to handle a larger number of transactions?
Yeah, great. Because scalability is one of the things that we feel the first. We feel most and we feel the first. If a transaction is taking long, it's a long time to confirm, or if I can only do 1 or 2 transactions per minute, this is something that we feel instantly. When we do a transaction in a bank account, in whatever money transfer application that you have, whenever you post something to a social network, all of those interactions are quick. So when you do something in a decentralized network, it takes much more time. And this is the first thing you feel. But that is quite, how do I say? This is quite misleading because there's something behind that you don't feel instantly. You are having more decentralization and you are having more security. You can't feel that so easily when you are doing a blockchain transaction. And this is because of CAP theorem of data availability, consistency, and partition tolerance of data that it's impossible to flee from. Because, like I said, blockchain is just a market for computation. So there is a nature law there called supply and demand. You have a fixed, a limited supply of information that can be transacted in that network per block, per second, per minute, blah, blah, blah. The more demand you have on that, the more clogged the network will be. So to solve that, the only way is to create more space, to be more efficient, to do some intelligent architectures like cross-chain protocols or layer 2, that the idea is when you need lots of security, lots of decentralization, okay, you do a very slow transaction. When you don't need so much security or you don't need so much decentralization, you can do faster transactions for lower volumes or whatever, and then you pack them together in a more secure location. So this kind of intelligent architecture can help us navigate around this problem. But scalability, throughput, every time you want to gain this, you need to lose a little of decentralization and or a little of security. Unfortunately, there is no way to have the 3 at the same time.
Can you explain how blockchain technology addresses the issue of trust and ensures the accuracy of information without relying on intermediaries?
Yeah, great question. Because we spoke about how blockchain is a shared network that a lot of people can run in their own computer, can participate. But one thing that is very important about blockchain networks is that they have a shared state as well. And this can be a chain, a blockchain that appends the state every time. Or you could have a block lattice, a block network, a block graph, a cyclical graph. There is this possibility as well. Well, one block is linked by others. All of this, those different designs, they do the same thing. They manage a state that is true for the network. What this state has, for example, my balance. How much do we have in this fund? How much do we have in this wallet? This is an information included in the state. How much is the price of that NFT? Information in the state. If everyone needs to agree on that, these states need to be shared between all the nodes. And whenever updating, this update needs to be agreed for everyone. To do that, there is something called consensus mechanism. This is what enables those blocks to append this state, to change the state. When these blocks are shared between all the nodes, they now they now implicate in a new state for the blockchain that everyone would agree on. And each new block appended would change a little the state more and more. Those blocks are made of transactions, but you could understand them as a whole as well, updating my balance, updating those values on chain every time they are received by the network. There might be problems in this consensus. There might be problem in the propagation of the network because it's not centralized. Have lots of different nodes. Sometimes they have faults, yes, but the consensus mechanism solves that as well. The blockchain technology can address those situations where you have faults in the network, because again, this is a Byzantine fault tolerant solution. It allows if at least half of the nodes or 2/3 of the nodes, depending, are okay, are not faulty, the network can survive.
Okay, Mateus, thank you. I have last question for you. How do you see blockchain evolving in the future, and what emerging trends or developments are you most excited about?
Well, I see a clear path for consolidation. I mean, reduction of noise. Blockchain at some point is going to be a normal technology. Like in the 70s, 80s, there was this talk about the internet coming, and then one new internet, or just a few amount of people were using internet, and then commerce, and then everyone is using internet. So there is not a lot of confusion about what internet is or isn't. There is no dot-com bubble anymore. So it is consolidated. I see Web3 and blockchain going that same path. I don't know if in a year, a decade, or a century, but eventually we are going to reduce, have the sparking of utilities out or inside payment as well, but out of payment, like social networks, like data wallets, governance, DAOs, identity wallets. And this Web3 concept as a whole, it's probably going to be a big upgrade when compared to the current Web2, that we don't have ownership of our own data, we don't have ownership about our own assets. They could be frozen, they could be taken at any moment. So the Web3 is a much needed upgrade in my opinion. Also, I'm very bullish for the possibility of junction of Web3 and AI. Many of the things that AI is missing, Web3 can solve. Many of the things that Web3 is missing, AI can solve. So the junction of those two technologies and those two potentials is what I believe that might change a lot humanity and how we interact as social members, as social individuals, the next few, by the amount of new things that can come from this junction.
All right, Matthias, thank you so much for this great conversation. And for the one who is listening, guys, if you're interested in reaching out to Matthias directly, don't forget to check the description below for all his contact details. And yeah, that's pretty it.
Thanks a lot, Adia. That was a great call. I hope it was enlightening. I hope it was enjoyable for everyone that is listening. It's great. Thank you very much. Bye-bye.